Okay, in this video we kind of recap what we've learned about polynomials so far, and then you're going to learn one kind of new thing. Okay, so here's what we have in the first problem. In the first parentheses we have 3x to the second minus 4x plus 3 minus, okay, 4x to the third plus 3x to the second plus 5x plus 6. Now, you don't have to do any rainbows because you don't have a multiplying operation here. You have subtraction. Well, you want to make it addition, then you want to make all these opposite. Negative, 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 negative. Now, you don't need to mess around over here. I'll have a lot of people that start drawing rainbows. No, the operation's adding, okay? It's not multiplying. This is like the first lesson we did in this. You know the degree right away on addition, subtraction. Degree x third is x to the third, and then you start lining up your spaces. So blank x to the third. So you don't have any x to the thirds here, you just got the negative 4 here. Then x seconds, you got a 3 and a negative 3. Funny thing about that is 3 plus negative 3 is 0. So we just don't have an x to the second anymore. Okay, because I had them, but I added them and they added to 0. Okay, after x to the second would come x. So you've got a negative 4 and a negative 5. So negative 4 plus negative 5 is negative 9. Okay. Then the constants, okay, 3, negative 6 would be negative 3. So again, you list your degree right away. And no, you don't label how many terms you have. That's what you do when you multiply, okay? Now this one is multiplication. You have negative x to the fifth, that'd be a 1, put a parentheses, and that would be times negative 9x to the fifth, 5x plus 13. Now, at multiplication, you don't know your degree till you do your work over here, okay? So, now you want to know how many terms there are. See, if it's adding or subtracting, I know my degree right away and I just go to town. But on multiplication, we need to count our terms, 1 and that's 3. So it's 1 by 3, so it'd be 3 products we need to find. So just think of it like this way, okay? If you're adding, subtracting, you know your degree right away. You line up your blanks. Multiplication, you don't know it. You need to do the work off to the side by distributing. So, negative 1 to negative 1 with its x to the fifth times negative 9 with its x to the fifth. Then back to negative 9, negative 1 with its x to the fifth times 5 with its x. Then negative 1 again with its x to the fifth times 13. That's going to give us our 3 products. So it's going to be positive 9. Now on x, remember you add the powers. You multiply the coefficients, but you add the exponents. It's x 10. Again, I'll repeat why that is. Because if I have x to the fifth times x to the fifth, that's 5 factors of x times 5 more factors of x. That makes 10 factors of x, so x to the 10th. Okay, then negative 1 times 5 is negative 6, or is negative 5. I just about screwed it up. Then x fifth times x to the first, so that would be x to the 6th. And then negative 1 times 13 is negative 13. And I'll have a lot of people that just put x there. No, you don't. You need to write x with its fifth power. Okay, you need to put the power that's there. A lot of times it's just going to be an x, but if the x actually has a power, please bring its power over with the 13. Okay. Okay, so x to the 10th, the degree is going to be 10 here. So we go blank x to the 10th, and then we have 9. That's the only one. We don't have x to the 9th. We don't have x to the 8th. We don't have x to the 7th. We do have x to the 6th, though. It's going to be negative 5. Then after we do have x to the 5th, and then I think that's a wrap on that one. Negative 13. So 9x to the 10th plus negative 5x to the 6th plus negative 13x to the 5th. Okay, next one, y plus 6 times y might, you need to put that times dot, because times means you do not have the degree. You have to go over here and find your products in order to find it, okay? So how many products do I have to find? Well, it's a 2 by 2, so I need to find 4. Okay, so 1y times 1y, then back to the 1y times negative 5, and that's the end of it. That's been distributed. Then 6 is also distributed, so it's 6, 6, 1y, negative 5. So 1 times 1 is 1, y times y, so I put first powers, and it'd be y to the second. 1 times negative 5 is negative 5. Now this is the only y I got. It doesn't have to be multiplied, and it doesn't have an exponent. Just put y down if it doesn't have an exponent. Don't put the first down, because that 6 times 1 is 6. This y doesn't have anything, does not have a partner of y, so it'll just be y. And 6 times negative 5 is negative 30. Okay, so the degree I know is y to the second. So blank y to the second, which I have a 1. Then after y to the second, I put just y without a power. And I have 2 of those terms, so those need to be added. Negative 5 plus 6 is 1. And then your constant, negative 30. So there's your answer, 1y to the second plus 1y plus negative 30. Keep your answer like that. In a textbook, the answer would just be y to the second plus y minus 30. They usually take the ones off in front of the variable, and they don't usually put plus negative, they just put minus. But that's how it looks in the textbook. Okay, my next problem, 4y minus 3 times, if you don't have an operator, it's a times automatically. And then 1y to the second plus 8y minus 6. That's another times, so we don't have the degree. We need to find our products. How many do we have to find? Well, that's a 2, and that has 3. So you guessed it, 6 products. Kind of not cool. That's as long as it gets, 6 products. So I go 4y, so I take 4y times 1y to the second. Then I go to the 4y times 8y. Now there's a third thing, so I go back to the 4y times negative 6. That's the end of that. Now I distribute the negative 3 to the 3 terms. So negative 3 times 1y to the second, negative 3 times 8y, and then negative 3 times negative 6. Don't be a wuss, just find the products, please. Don't be a whiner. 4 times 1 is 4. Then y times y to the second. Well, I put a first power, so I know what to add. 1 plus 2 is 3, so that's 4y to the third. Okay, 4 times 8 is 32. And then it'd be y times y, which is y to the first, which would be y to the second. Then 4 times negative 6 is negative 24. Now there's a y here, but not here, so I just put y. If it doesn't have a power, so be it. Okay. Then negative 3 times 1y to the second. Negative 3 times 1 is negative 3. Then that doesn't have a y, that has a y to the second. So I just put y to the second. So that didn't have to be multiplied, but it still has to keep the power that it has. It doesn't have, like up on the one before, it didn't have a power, so I just put y. But if it has a power, put it. Okay. Negative 3 times 8 is negative 24. And there's no y. This is my only y. It doesn't have a power, so we'll just keep it without a power. It's technically to the first, but we don't need that when doing this. Negative 3 times negative 6 is 18. I really only put first powers if there's another y in the problem, so I know exactly what I'm adding. But if I know I'm not going to add, I just put the y the way it is. Okay, the degree is 3. Degree is y to the third this time, so blank y to the third, and you got 4. Then do you have y to the seconds? Yeah, you actually have a couple of them. 32y to the second and negative 3y to the second. So plus blank y to the second, and those need to be added. 32 plus negative 3 is 29. You're adding them. Okay, after y to the seconds come y. Y to the first technically, but that's, again, we kept it as y. So negative 24, negative 24. Add those two, that's negative 48. When you're adding two negatives of the same number, it doubles it. Then the constant, you have 18. And there is your product. That's as long as it gets. Okay, now the back three problems, you run into something you haven't seen before. This is what you don't do. And I see a lot of people do it, but I'm going to explain why this doesn't work on this problem here. Y plus 6, okay? People will start drawing the three lines. They'll put a y plus a 6. They'll put ones and then times them by 2. You can't do that, okay? You can do that if it's y times 6, but with that addition sign, circle that. You need to do a different method of simplifying. What you need to do when you have an expression that contains a plus sign or a minus sign with an exponent, you need to get rid of the exponent, write times by a second parentheses, and just copy what's in the first, y plus 6. That is how you deal with a sum to the second power, sum meaning a plus sign. An expression that includes a plus or a minus operator to the second power. You get rid of the second power, make another one just like it. Now, I'm not going to be mean and do this, but if that was a third power, you'd make a third parentheses and copy it. Okay? So you got 1y plus 6 times 1y plus 6. So we don't know the degree because it's a times. So it's a 2 by 2. So we find the four products. Now it's something you know how to do. So 1y times 1y. It's a FOIL method. Then 1y times 6. Then 6 times 1y. And then 6 times 6. So 1 times 1 is 1. We have to take y times y. So y to the first would be y to the second. 1 times 6 is 6. Now this is the only y I have, so I just put y. If it doesn't have a power, don't put a power. Same on this one. 6 times 1 is 6 with y. And 6 times 6 is 36. So the degree is y to the second. So 1. Then y's. 6 plus 6 is 12. Then constants. 36. See, if you do it that way, you're never going to get that 12y in the middle. I mean, that'd be y to the second plus 36, but then you would be missing your 12y, so that ain't going to work, okay? Okay, and minus 11 to the second. That minus can be made a plus negative, because so you have an addition sign within an expression, and that whole expression is to the second power, so you cannot make the three lines. You need to remove the second power, write it times, make another parentheses, and put one just like the first. Because anything the second is a number times something times itself. If it's a whole parentheses to the second, you just duplicate it. Now we didn't do that in the last chapter because we had another way of doing it, because we didn't have any addition signs operators at the beginning of the problem. So it was all just a monomial. Okay, so we don't know the degree on a multiplication until we find our products, all of them. So 1n times 1n, 1n times negative 11. Then negative 11 times 1n, then negative 11 times negative 11. So 1 times 1 is 1, n times n to the first would be n to the second. Then 1 times 11 is negative 11. That's only n, just copy it down. Negative 11 times 1 is negative 11. Copy the n factor. And then positive 121. So the degree we now know is n to the second. So you got 1. Negative 11 adds to negative 22. and the constant is 121. So 1 n to the second plus negative 22n plus 121. Now my next problem, we have 2y plus 5 raised to the second. So again, there is an exponent, it's an exponential expression, but with that plus sign, you need to duplicate the sum, is what I call it. So sum of the same two things. Sum means add, minus means difference, but minuses can be made into sums, put the plus negative. So again, I don't know my degree till I go do my work. Okay, it's 2 by 2, so you go 2y times 2y. Then 2y times 5. This should be getting automatic now, on a 2 by 2 anyway. Then 5 by 2y. And then 5 times 5. Find your four products, and then you'll know what degree you have. 2 times 2 is 4, and on y, 1 plus 1 is y second. 2 times 5 is 10, and then if that's your only factor of y, just copy it down as it is. 10, copy the y down as it is, and then 25. So to the degrees of y to the second, with a 4 coefficient, and the y coefficient, well, we got two of them, so we combine those. 10 plus 10 is 20. And the constant, 25.